Ladies and gentlemen, welcome for our 12th and last launch of the year from the Guiana Space Center, the third with Soyuz. For today's mission, Soyuz is set to deliver 2 Galileo satellites manufactured by OHB System into a circular medium Earth orbit at an altitude of 23,522 kilometers and inclined at 55 degrees above the equator. From liftoff until separation, the mission elapsed time will be approximately 3 hours and 48 minutes. Both satellites will be released simultaneously. Following the launches of 2 other pairs of Galileo satellites and of Copernicus Sentinel-2A by Soyuz and Vega respectively, this mission is the 4th of the year to be performed by Arianespace for the European Union. In all cases, mission integration was made in the framework of a contract signed with the European Space Agency, responsible for Galileo and Copernicus space segments. After today's launch, Arianespace will have orbited 12 satellites for Galileo and 2 for Copernicus. We are thus very grateful to the European Commission and European Space Agency for their continuous trust in our launch systems. It is a source of great pride for us to provide European governments and institutions with independent access to space thanks to our launch vehicle family. And we are ready to go on delivering for ESA and EC next year with Ariane 5 for Galileo and with Soyuz for Copernicus. I shall add that we are proud to contribute to sustainable development with our launchers family in the year of COP21. But our 13th Soyuz to be launched from French Guiana is now being readied for liftoff, so enjoy the show.
Greetings, everybody, wherever you may be, and welcome once again to French Guiana, the home of the Ariane family, for today's live broadcast of Arianespace's 13th launch of the Soyuz. And we are going for a record tonight. All is go for liftoff. Soyuz waiting on the pad, her mission to deliver 2 more satellites to the Galileo constellation. You can follow all the play-by-play in English with me and with my friend Stéphane Lodo, up there in the broadcast booth. Sylvain is ground segment manager. Hi there. Or you can follow in French with Pierre Junier, who's also in the broadcast booth. Pierre. All systems are green, which means we are go for launch on time, on target. The one system we can't, of course, control is the weather, but we'll be optimistic. The 2 new satellites are going to add to those already orbiting in the independent Europe satellite navigation fleet. We're going to have a lot more on Galileo in just a moment, so stay with us. For those of you looking for the first time at Soyuz, she stands 46 meters tall, 4 stages. The first stage consisting of 4 boosters, each with its own engine. The boosters clustered around a central core, which is the second stage. The third stage weighing in at about 25 tons roughly, producing 30 tons of thrust. Atop this 3-stage assembly and under the fairing is the upper stage called Frégate. There's also a dispenser for the 2 satellites and the 2 passengers, of course, Galileo 11 and 12. Frégate was designed to be an independent orbiter, and she can be reignited, which is important. We'll be coming back to that a bit later. Soyuz weighing in at just over 300 tons. Arianespace's middle-sized launch vehicle, lighter than Ariane 5, but heavier than Vega. We like to start the broadcast by showing you some of the key players involved in making the mission happen. We're coming to you live from the Jupiter Mission Control, as always, and you're going to be looking into the flight directorate here. This is the High Command, led by Stéphane Israel of Arianespace, of course. With him, Louis Laurent, who's the Senior VP for Programs. Along with them, Igor Novikov of Roscosmos, that's the Russian space agency. And rounding out the team from Arianespace, Edouard Perez, the Chief Technical Officer. Edward Perez is the living technical memory of all Arianespace flights. Flight information comes in here to Jupiter from across the base, which is why we call Jupiter the nerve center. Anything unexpected comes up during the mission, and these men will make the call what to do about it. The mission tonight for ESA, the European Space Agency, and we have an interview with their Director General, Jan Werner, coming up for you in just a moment.
Hello everyone, witnessing the launch of Galileo 11 and 12. Galileo is a flagship program of the European Commission for satellite navigation. And we have already 1/3 of the whole fleet in orbit, meaning 10 satellites are already in orbit. And now we are launching 11 and 12. It's the third launch this year, and this is a special challenge also for the people and the staff in Kourou. ESA is responsible for implementing Galileo, so we are responsible for all contractual and technical aspects. And therefore, I hope that we will witness a successful launch for being another step to complete Galileo navigation system in orbit.
We are going to stay with ESA because we're very happy to have with us Mr. Didier Fevre, the agency's Navigation Program Director. Welcome.
Thank you, Josh.
We're going to find out more about Galileo. We have just about 2 or 3 minutes. We're going to do that. Let me start with this. We're 1/3 of the way into deployment of Europe's independent satellite navigation system. Now, how important is that word, independent?
Independent means that Europe has decided almost 15 years ago to master a navigation system, to master the technology, to master the operations, and to be able to deliver with its own means full navigation services to the world. This puts Europe at in the club of the few space powers able to manage such a complex system.
All right, compare Europe in the club to the existing system. How does the Galileo system stand up to the American, the Russian, and the Chinese systems?
So today, of course, the main player is GPS, which is everywhere in the world with an excellent performance. But with the first satellite already launched by Europe, in terms of performances, we are at par, at a right level of performances. And we intend to stay at this level and even be number 2. Close to our friends in the US. Our system is fully interoperable with the US system.
Okay, talk to the average consumer now. How do I use the system if I'm trying to connect from my car or from my boat? What do I do?
If you are a normal customer, a normal user, not customer because it's free. If you are a normal user, you will have access to the Galileo services the same way you have access to GPS because the open service is fully interoperable. So meaning that from your perspective, you access new satellites, meaning a better geometry, better services, but without changing anything. The receivers today are already able to receive the Galileo signals. If you are a public servant, if you are belonging to the public services, you will have access to something special.
So all I need is my handset and I'm ready to go?
Yes, if your handset is able to receive, but now they are like that.
Okay, look back over the year. We had a launch similar to this one in September. We had Galileo 9 and 10, I think. How many times have we launched this year?
We had the launch in September, but also a launch in March, meaning that we had 3 launches this year, 6 satellites in less than 9 months. This is excellent for the program. It shows that the pace of production by industry is good, and the tests are also done in time, and we can launch that. This makes the deployment good for us.
So the pace is better than good. It's been stepped up, I guess, right?
Yes, of course.
Is that
but
fair to say?
we are beginners, so we are making progress. And now we're extremely satisfied with the production rate, the test rate, and the launch rate.
Okay, now full deployment is how many satellites? And when can we see full deployment?
Full deployment is 30 satellites by 2020. We need 24 satellites to be fully operational, but we have decided to have spare satellites in orbit to make sure that the service is offered every time, everywhere in the world.
6 spares, I believe, right?
6 spares,
backups.
yes.
So 1 spare for each 4 or 6 satellites.
We have 3 planes, 8 satellites fully operational, and 2 spares operational, but which are on top, let's say.
You just heard the DDO's voice calling out the milestone. We're into the final launch sequence, so we're rolling just as we should be. All right, in the minute left to us, let's look ahead. Next year, we're going to look at upgrades to the system, and we're also considering under review the 2nd generation Galileo. Tell us about those.
Let's first deploy. I said 2020. But because what we do is long development, long deployment, we're already preparing the future. First, we will put on EGNOS, which is a European system, Galileo on board.
That's the civil aviation.
Civil
right?
aviation
EGNOS?
over Europe, safety of life services. The first thing we will do is to put EGNOS able to acquire and work with Galileo. This is a total change of the system. And second, we are now preparing the next generation for the satellites to be launched in 2325.
325. Can we talk about clocks? Because I know we have atomic clocks, the world's most precise atomic clocks on board.
Yes. In Europe, we have developed the most precise atomic clocks, maser clocks, performed by European industry. We are very proud of that. And that's the best satellites. The best clocks today flying in orbit are Europeans.
The best is European. Okay. Last question. We don't have much time, but you've been working with the program for about 10 years. What are you going to remember most when you leave?
10 years, 8 launches, 14 satellites, but probably the most intense moment in the last 10 years was in March 13, where we are able in Europe to have the first positioning with only European means, European satellites, European ground segment, European brains at the end.
Okay, very good. I think we're out of time. Didier Favre from ESA, many thanks to you. Didier is going to take his place inside the fishbowl. I've got to make it back up with Sylvain in the broadcast booth. While we're shuffling around, take a look at this film, which is on the launcher campaign, and you can see how our Soyuz is put together. Back with more later. The MIC integration building is where Soyuz is assembled. Here, the first 3 stages of the launcher are put together horizontally. The 4 boosters, each with its own engine, were fixed around the core second stage. The 3rd stage was then integrated on top of that. All these stages of the Soyuz come to French Guiana by ship from St. Petersburg. The 2 Galileo satellites arrived at the space base by plane. They were then transferred to the Space Center, where they underwent a series of tests to confirm that all their systems were functioning normally. Once these tests were carried out, their fuel tanks were filled. The 2 satellites were then fixed symmetrically, one after another, on their dispenser. The frigate upper stage was filled in the new frigate fueling facility. It then moved to the S3B satellite building, where the Galileo 11 and 12 satellites were integrated onto it. The fairing then covered this upper composite. On D-4 days, after another series of tests, the launcher left the MIC building. It was rolled out horizontally to its place on the launch pad and then raised vertically. A gantry lets technicians work on all the different stages of the vehicle during its preparation. It keeps Soyuz protected until 1 hour before liftoff. The upper composite with its passengers was in its turn transferred to the launch zone, raised vertically and integrated onto Soyuz. All her electrical and fluid connections were then checked. Over 100 Russian and European engineers and technicians are working inside the Soyuz Launch Operations Building. The building stands 3 kilometers from the launch pad. These teams are managed by the COEL, or the Launch Operations Manager, today Jean-Claude Garot of Arianespace. The Russian team is led by Alexander Sharavan, the Russian Launch Operations Manager. The Launcher Technical Authority, Mark Grozich, oversees the vehicle's readiness for flight. His Russian counterpart today is Andrei Mezhevikin. Here in the Soyuz Launch Operations Building, the working languages are French, Russian, and English. 2 quality managers for the launch campaign assure launch production quality. Arianespace follows all operations from Moscow. Another team here in French Guiana is made up of people who interpret and transmit all telemetry data coming from the launcher to the ground stations. At the Soyuz Launch Center, Antoine Courtois heads up the Immediate Visual Control Center, where telemetry is received. These people look at all data from speed and propulsion to stage separation. All these players are ready for launch of the 13th Soyuz. All right, back with more. Joshua Jampo with Sylvain Lodo. I got your name right this time. Sorry about that.
Okay.
Ground segment manager for Galileo. Glad to have you here.
Yes, welcome also to everybody listening, and in particular in the operational sites. I'm thinking about Toulouse in particular, this case, at ESTEC, and also to the ESA Council meeting in Paris today.
All right, we had the Klechna start, which came at -5 minutes and 9 seconds. That's the hand-driven key opening start to the final sequence. That's done up at the launch center. We're going to go to our first film now, a presentation of the mission.
Let's have a look on the launcher, which is composed of two parts. The first part is the Soyuz STB, composed of 3 stages. The second part is the nose module, composed of the frigate stage and the 2 satellites. During 9 minutes, the Soyuz STB ascent phase will take place. After that, the nose module will be injected into a suborbital orbit. After that, the frigate stage will manage a first boost of 13 minutes to inject the nose module into an intermediate orbit. Then, during 3 hours, a long ballistic phase will take place. After that, the frigate stage will manage a second burn of 4 minutes in order to put the nose module into the separation orbit. At last, 3 hours and 48 minutes after the liftoff, the simultaneous separations of the 2 spacecraft will occur.
We are focusing on the launcher during this initial part of the broadcast. We'll have plenty of time to turn to the satellites once Soyuz has left the pad, and we'll get Sylvain's expert commentary on not only the ground stations, but on everything in the system, right?
I hope so, yes.
All right, at minus 2 minutes and 35 seconds, you'll hear the DDO call out that the electrical umbilicals on the satellites have been released. That's the next milestone to watch for. That's separation chow connector, is that right? Is that what that is?
Yes, that's correct, yes.
And then that's the, we won't really see it, but we'll hear him say that the release of the umbilicals. And then you'll hear the DDO call out many more milestones, the release of the masts, which comes at what, minus 20 seconds, I think. It's very exciting to see one by one the peeling of the
steps.
onion, things fall away until liftoff. This man is the DDO.
À tous DDO, attention, largage des ombilicaux, ciao.
Those are the umbilicals that we're talking about. The DDO is the range operation manager. All the reports from all the systems across the space, which is 700 square kilometers, and includes everything we need to prepare, launch, and follow. So all the information comes into him, and he relays it to us. 2 minutes to go. About an hour ago, the gantry was moved back about 80 meters, revealing the launch vehicle, which you can see there. Some other launcher preparations that have already taken place.
Yeah, it's at minus 3 hours and 30 minutes. We fill the tanks with hydrogen peroxide, and this took 20 minutes.
Then at minus 3 hours, 10 minutes, sorry, we filled the tanks with liquid oxygen.
Yes, this time, yes. And at minus 2 hours 55, we fill it with kerosene.
So there's 3 different fuels that are used on the first 3 stages.
Correct. Yeah.
Of Soyuz. There's liquid oxygen, hydrogen peroxide, and kerosene. The upper stage, the 4th stage, of course, is cryogenic fuel. The people in the hall here, as we approach 1 minute, you'll hear the DDO call out 1 minute. People in the hall going out to the balconies to watch the liftoff.
À tous de DDO, attention pour H0 moins 1 minute. Top H0 moins 1 minute.
We're into the final 60 seconds. We just want to mention the launch, the ignition sequence. The ignition sequence is in 3 stages. From minus 17 seconds, the engines are tested automatically.
Yeah, and at minus 15 seconds is the first control ignition at about 20% of the total thrust.
And then there's a second, minus 7 seconds, intermediate pressure check. There you see the arms falling away. That's always an exciting thing for me to see the arms fall away. And then at minus 3 seconds, the order is given for the 3rd and final phase, full throttle.
Attention pour le début de la séquence d'allumage du lanceur.
The DDO is going to call out the final countdown. We'll be back after Soyuz has cleared the tower. Enjoy the liftoff, everybody.
Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, unité, décollage. à bord sont nominaux. Les moteurs des premiers et deuxième étages fonctionnent
And we
normalement.
are underway. Soyuz lifting off perfectly once again from French Guiana, beginning her 13th mission from the spaceport. Sylvain, what went through your mind as you watched liftoff?
It's very thrilling, as always. It's a very nice thing to see. Quite impressive.
No matter how many times you see it,
Yeah,
it's
it's always the
always
same thing, yes.
beautiful. 300 tons at liftoff, roaring through the sky. That's less than half the mass of Ariane 5, you recall. Those of you familiar with the Ariane 5 launches, saw Soyuz rise a lot more quickly. The boosters and the central core, or the second stage, are burning now. The boosters...
Yeah, the boosters, they weigh 45 tons each at liftoff. Total mass is of the first stage is 178 tons. So the engines run on liquid oxygen and kerosene, as we said. Yeah, the same propellants which are used for each of the three lower stages.
The second, or the core stage, is similar to the boosters. Its ignition occurred on the pad, as you saw. This stage will burn for about 4 minutes. We're coming up on separation of the boosters in just about 10 seconds. And then you'll see, remember, Soyuz lifted
Les paramètres
off.
à bord sont normaux, la trajectoire est nominale.
The DDO is saying everything is nominal, normal on board. We're going to see separation of the boosters in just a minute on the simulation there. There it is, right on time. Now remember, Soyuz weighed 300 tons at liftoff. After separation of the boosters, there's the onboard camera showing them falling away into the ocean. She's down now to how
Extinction des
much?
pousseurs latéraux et
What does she
séparation
weigh
des
now
quatre blocs
after the
latéraux
boosters?
BVGD.
Less than half its weight.
Less than half.
Yeah.
Yeah, I think it's 135 tons, roughly.
Yeah, something like that, yes.
Les paramètres du lanceur après séparation sont toujours nominaux.
All right, Soyuz, remember, is complementary, not a competitor to Ariane 5. She's lifting 2 satellites, total payload weighing about 1.5 tons this morning, while Ariane 5 can lift, of course, 10 tons. There are many differences, though. The boosters are the first stage. That's one of the differences.
Le fonctionnement du moteur du second étage est nominal.
Coming up to the jettison of the fairing, that's in just under a minute. And you'll see Patrick Loire, head of Arianespace facilities here in Kourou, giving us a thumbs up, because all is going well with Soyuz. She departed right on time. Soyuz, you know, goes back to the first days of the space race.
Yes, for sure. Yeah.
She goes back to 1966, I think, right?
Yeah, it was the workhorse of the Soviet program.
Les
And
paramètres
continues
de pilotage
working.
et de propulsion à bord sont nominaux.
Very well indeed. Yeah, it's very reliable, efficient, flexible.
And cost-effective.
Also, yes, I
Yeah.
believe, yeah.
And which makes Soyuz good for any kind of mission. I think Soyuz has done every mission possible, from
La trajectoire est conforme à
telecoms
l'attendu.
to Earth observation,
Yeah,
right?
weather probes,
Weather probes, yeah, science probes, Mars missions. She
Yeah.
takes people to the
people,
ISS, the
exactly,
space
yes.
station.
Yeah.
There's the fairing jettison. You can see leaving exposed to the elements the 2
Séparation de la coiffe.
satellites. Those are the black boxes on the end. Now, why can we can get rid of the fairing now because we don't need it anymore, right?
Yeah, because now we are getting out of the dense layers of the atmosphere. So we are above 100 kilometers. There you see we are 124 kilometers at that moment.
That's right. On the bottom, Sylvain referring to on the bottom altitude
Les
left,
paramètres
on
à
the,
bord de
bottom,
propulsion et de pilotage
on the
sont
bottom
normaux.
left, and on the bottom right are speeds. All right,
Yeah.
go ahead.
And at this altitude, you have neither friction nor heating. So we discard any dead weight, in fact, to maximize the launch capabilities.
Le fonctionnement du
Does that
moteur
help
du
us go
pilotage
faster? Not
nominal.
necessarily, no?
Well, you have less weight, so it's a bit more efficient. Yes, we don't need any weight protection any longer, so we can remove it.
All right, tell us about our trajectory now. We're flying north now, and we're going to go over the Azores, I think.
Yeah, at the point in time, we'll fly, yes, close to Azores, yes,
Yeah.
going to over Europe.
And then we turn east, that's right, and we go over
Yeah.
Europe. And then we will fly down over Russia and over Australia, I think. Is that
Yes,
right?
the South Indian Ocean, close to Australia, yes.
You saw the second stage separated and the third stage ignited there. One particularity of the Soyuz vehicle is, whereas with Ariane, we separate the lower stage before
du deuxième étage.
igniting the upper stage. Soyuz is just the opposite. The third stage
Allumage
is
du troisième
ignited
étage et acquisition de la tête
2
du lanceur
seconds
par la
before
station
separation
navale.
of the second stage. Now, the lower part of the third stage, called the skirt, is used to channel the flux of this third stage motor ignition down toward the stage below where it rebounds, which gives an added thrust, assisting separation. Is that right?
That's correct, yes.
And I think you saw the parts of the skirt being blown away there.
Being blown away, yes. And during those 10 seconds, in fact, Soyuz climbs 4 kilometers, so from roughly 149 to 153 kilometers.
In those 4 seconds, good.
Yeah.
Giuliano Gatti, we'll be hearing from him a little later on, telling us about the low Earth orbit operations, the first operations after separation. Shortly, we will be picked up by one of our first ground tracking stations, not on the ground actually, but in the ocean.
In the ocean, yes. This is the first one to pick it up after the one from Galileo, the Galileo one here in Kourou.
There's a station here on the hill behind us, and this station called SNA is a boat that's in the middle of the Atlantic.
Yes, in the Atlantic, yes.
And that's only used for Soyuz. It's not used for Ariane or Vega because normally they don't fly.
Yes, they don't fly in the same way, yes.
All right, the series of ground stations, which is your pursuit, follows the launcher all during its flight and picks up all the radar and telemetry. We'll be hearing more later. For now, we can go to a launch replay, the first of what we hope is going to be many replays, and you can relive those exciting moments just under 7 minutes ago as Soyuz first left the pad. Well, maybe not. We're supposed to have a replay, but the ground stations, you can see them there. SNA is the boat. Azor, Santa Maria Station. Osagel is where?
Close to Toulouse, yeah.
In French. So,
Yes.
so at that point, Soyuz is already heading east.
Yes.
Over Europe. So she flies from Galileo over the boat, which is SNA, north, and then north over the Azores.
Yes, correct.
And then makes her trip starting to go east. And the satellites will be separated over Australia, you say?
Yeah, close to Australia. It's over the Indian Ocean, but it will be the last station to follow it is for the launcher is from Perth in Australia.
Right. Okay. And that station's used in a lot of tracking for a lot of.
Yes, these kind of stations are used for many missions. Yeah. They're tracking stations for this purpose. Yeah.
Yeah, so it's an international cooperation because these stations work for NASA, they work for Arianespace.
Well, in this case, we are talking about a station which is tracking Soyuz for sure. Then, when we talk about the launch and early orbit phases, what they will be doing from Toulouse this time. In fact, they use a network of stations which are in fact located around the world, and they will use then other stations to track those satellites.
So we can say that it's this international cooperation effort.
Yes, for this kind of programs, you are constantly using worldwide networks, and you effectively share this infrastructure for many missions.
Okay, our altitude 180 kilometers, our speed over 6.2 kilometers per second. What is ESA's role in the Galileo program?
In Galileo, so ESA is, in fact, the architect of the system, to make it simple.
Which means?
Well, we have designed the system, we are developing it, and we are deploying it right now.
Right.
So, and we are, in fact, in charge of making it work. Yeah. Simply.
So the origin of Galileo is with the European Space Agency.
Well, ESA has played a big role. Now we need also to talk about the European Commission, who is in fact the program in charge of the program now.
And they're here tonight.
Yeah, of course, they're here and indeed, and they are in fact, for instance, they are now financing the whole program, and they are of course the political lead.
Okay. There are three main bodies involved in Galileo. There's ESA, and there's, you said, the European Commission, and there is also
and we should talk about the GSA, which is the European GNSS agency.
The European
GNSS, so for Global Navigation Satellite Service Agency.
Global, yeah. That's right. Global. Say that again. Say that again. The Global Navigation Satellite System from Europe. Okay, correct. Here's your replay. A little late, but better late than never. Soyuz rising right off the pad, trailing all that fire. We'll have more replays for you later on because we have other cameras at other outposts. You were talking about the GSA.
Yes, exactly. And the GSA was created to implement the services for Galileo. Mm-hmm. So they're in charge, for instance, of maximizing the use of the Galileo signals.
It's another replay there, as promised. Can we talk about the stations now, the network of stations?
Yeah. So we could talk. There are several network of stations. So we talked about the ones related to the launcher follow-up, and there are also the stations which will be used for the LEO.
Information tardive de la séparation du bloquis et de l'allumage frégate.
So we just had
The first
scheduled first ignition of the upper stage, the frigate stage. Now this burn will last about 13 minutes. There will be a second burn which will take place in about 3 hours and a quarter. That'll last about 4 minutes, but we'll get to that. We'll get to that a bit later. If you've just joined us, the first 3 stages on the Soyuz have done their work. Only the frigate upper stage is burning now. You started to talk about the stations, but maybe you want to tell us more about frigate.
Yeah, so frigate, it's an autonomous, flexible upper stage, and it's a relatively recent addition. It was qualified around 2000, and it has been designed to operate as an orbiter, in fact.
Yeah. Now this is so this version of the Soyuz is an updated version of the one we were talking about before that goes back to the first days of the space race.
Yes.
It's the same basic system, but the frigate was not part of the original Soyuz.
No, correct. This is much more recent.
Right, okay.
Yes, 15 years ago, yeah.
So if the first 3 stages of Soyuz, tell me if this is right, first 3 stages are basically Russian, then the top stage, the frigate, which is what we're looking at now, is a European stage. Is that?
No, frigate is also Russian.
Frigate is also Russian?
Yes.
Okay, produced by NPO Lavochkin.
Mm-hmm. Correct.
And mass at liftoff of about 6 tons. All right, why don't we...
Acquisition de la
Didier is going to call out. You might have noticed a slight delay.
Fonctionne nominalement et acquisition de la télévision lanceur par la station de Santa Maria des Açores.
Okay, we're going to go to our first film on Galileo. We'll be hearing, I believe, from Didier Favre again.
Kourou, French Guiana. At the European Spaceport, 2 more Galileo satellites are being prepared in the clean room dedicated to the Galileo program. These facilities are no luxury, as ESA and the Galileo program have had a very busy year, with a massive output and a good pace to keep up. But all the hard work was definitely worth the effort.
2015 is a great year for Galileo. A launch in March, a launch in September, a third launch in December, 6 satellite launch in 9 months. The Galileo deployment is now going full speed ahead, and next year we'll have not a completion, but a sufficient number of satellites to achieve tests at high level. So it's very good for the program, this launch today.
What is also very good for the program is that in the course of only 1 year, the number of Galileo satellites in orbit has doubled. And now 1/3 of the constellation is up and running, with the ground segment also deployed worldwide. And the program is on track. Once Galileo 12 have been fully checked and are operational in orbit, first services should start by the end of 2016. Now, after the successful in-orbit validation phase of the system, ESA is taking full advantage of a return of experience based on several years of operations. 2015 also marks the historic milestone of the 10th anniversary of the launch of the GOV-A satellite on the 28th of December 2005. GOV stands for Galileo in Orbit Validation Element. It was the first test satellite for the Galileo program, proving the quality of the first navigation payload built in Europe, and since then ESA and Europe have come a long way.
In the last 10 years we have had 6 operational launches, plus 2 GOV, 8 launches, 14 satellite launched, a ground segment deployed all over the world, an excellent performance demonstrated in March 13 with the first positioning, EGNOS now operational and ready to augment Galileo on top of what EGNOS does already with GPS. So 10 years demonstrating that Europe joins the club of the powers mastering navigation. Things are going well.
Galileo and EGNOS are perfect examples of Europe's expertise in the technology field, with Galileo providing users worldwide with publicly owned high-quality satellite navigation and a timing platform, and EGNOS now being implemented in air traffic management for civil aviation. ESA and the European Commission must now prepare for the provision of Galileo services for the citizens in Europe and beyond. 10 years after the launch of the first satellite, Galileo is a reality, and Europe has its autonomy in satellite navigation.
That's a point we keep coming back to, this autonomy provided by Galileo. You may have noticed that since the start of the mission, there's Didier again, since the mission, events announced by the DDO come in with a slight delay. Now, this is quite normal. The reason being that all the information we mentioned, the telemetry and the radar, coming into the ground stations, they're sent from them here to Jupiter, but they have to go to Moscow first.
Yes,
right?
correct.
They have to be confirmed.
To be confirmed there, yeah.
By Moscow. Then they come into French Guiana, where they go to a place called the CVI, the Immediate Visual Control Center. Will be. We looked at that during the film on the launcher campaign.
Yeah.
From the CVI here, then they're relayed to the DDO here. So it can take more than a few seconds.
More than a few seconds, yes, you're right.
Okay, just so you're aware of that. Where are we? I want to know about your job. You're ground segment manager for 11 years. You've been doing it.
Yes,
what do you do exactly?
For 11 years. Well, in fact, I've been following the full cycle of development for the ground control segment and for the ground mission segment in particular.
So even before, well, obviously before the first satellite went up, you were there
yeah, of course,
on the ground station.
To build that, and then it was ready to support the satellites that we launched initially, yes.
So how long before the first satellite launch do you have to be starting to prepare the ground segment?
In our case, okay, we started development in 2005, and the first satellites were launched in 2011. So this was
6 years.
Yeah, it's a long development cycle for sure.
And that's for the entire ground system.
Yes, for the control segment and the mission segment. But then still today we are implementing important upgrades because we need now to make the system more reliable.
All right, we're going to talk about those upgrades in just a moment. But for now, we're going to another film on Galileo, how it's going to be used, and we'll be hearing from the people at this global satellite agency that you talked about.
Since its certification for civil aviation in 2011, EGNOS, the European Geostationary Navigation Overlay Service, has gone from strength to strength. EGNOS is a satellite-based augmentation system that improves GNSS positioning using 3 satellites and a network of more than 39 reference stations in 24 countries, providing much greater accuracy than achieved through GPS alone. Recently, EGNOS added a new service, LPV-200. Pilots rely on instruments for most of their approach. However, in the final stages of the landing procedure, they have to decide whether it's safe to land based on what they can see. The additional accuracy of the EGNOS LPV-200 service lowers the altitude at which the pilot has to make that decision to only 200 feet above the runway.
The decision height's important because that allows more accessibility to airports in poorer weather conditions. So essentially, the lower the decision height, the better access that airport's going to have in poorer weather conditions.
EGNOS reduces risks associated with landing in bad weather, increases accessibility to airports, reduces delays, diversions and cancellations. By increasing airspace capacity and lowering both air traffic control and pilot workload, EGNOS improves safety and increases efficiency of operations, whilst lowering fuel consumption, CO2 emissions and noise levels. The service requires no upgrade to an airport's ground infrastructure or to existing certified EGNOS receivers, and offers the same decision height as ILS Cat 1.
We started off with the basic LNAV approach, and that minimum was 500 feet. An LPV using EGNOS brings it down to 250 to 300 feet here. When we get LPV 200, that will come down to 200 feet, so the aircraft can be a lot lower before it has to initiate a missed approach. LPV 200 will mean it's near enough identical to our Cat 1 ILS
The European GNSS Agency has worked continuously with aircraft manufacturers, airspace users, aviation authorities and airports to help integrate and adopt EGNOS.
Every aviation GPS receiver we sell today includes EGNOS as part of its chipset. And in fact, I don't think we've sold a receiver for the last 7 years that didn't include EGNOS capabilities.
As of October 2015, 271 EGNOS-based procedures in 157 airports had been developed, and every month more airports are adopting EGNOS.
I think there's a great future for this system because it will permit many airlines to operate in many airports that now don't have the proper facilities.
Most navigation systems in aircraft and helicopters can now use EGNOS, including the new ATR 600 series and the Airbus 350 XWB, both of which offer EGNOS-enabled avionics. Furthermore, EGNOS is still improving. EGNOS version 3, which will integrate Galileo, is under development, and EGNOS will be extended across and possibly beyond Europe. Thanks to the LPV 200 service today and the future evolution of EGNOS, European aviation will become ever safer and increasingly efficient.
Okay, so you see that it seems that all is proceeding nominally on board. You can see that we are now at an altitude of 383 kilometers and still, of course, increasing it very fast now. And while you were watching that film, in fact, we've picked up our downrange tracking station in Osagel.
That's the one in France.
Yes.
All right, now we're talking about the ground segment, we're talking about the space segment. Space segment, I assume, is the satellite.
Yes,
right?
exactly, the satellites.
Right.
So we are, in fact, to deploy, as was said by Didier, up to 30 satellites.
Right, that includes 6 spares.
Yes, in fact, the nominal constellation is 24 satellites, 8 on 3 planes, but we are also having 2 in-orbit spares to ensure a good availability of the system.
Now you say different planes, these are different orbital planes.
Yes, exactly. We have 3 planes. In fact, these planes are the orbits we are flying, and they are separated from one another by 120 degrees.
All right, we have had extinction of the first frigate burn, the scheduled extinction. We're waiting for confirmation to come from the DDO, but as we mentioned, that takes a while. So now we're into what we call the ballistics phase. The first burn is over. So yeah. We're starting our long coast. We're going to be coasting for about 3¼ hours.
Yes, correct.
Now, why do we have to do that?
Tous les systèmes bord fonctionnent nominalement. Les paramètres à bord sont conformes à l'attendu.
DDO says everything continues to function normally on board. Why do we have to coast for so long now?
Yeah, because now we have to reach in the orbit the moment where we want to circularize our orbit.
Circularize, meaning?
To make, today we are on a kind of elliptic orbit, and then we will have to make it a circle around the Earth, because this is what is the orbit for Galileo satellites.
Ah, okay. So that's what we need the ballistics phase for.
Yes.
Because this is called the ballistics phase, or sometimes they call it a space ballet.
Yeah.
Is that right? Yeah, because they're. So what's happening now? We're coasting, but are we turning in any direction, or what?
No, now we are effectively coasting. We will do, in fact, because at this level there is, in terms of environment, you have important differences in temperature from different sides of the spacecraft. So it can be.
Du moteur principal de l'étage frégate.
Now we have the confirmation of the frigate cutoff, which was scheduled for plus 2332. So you see, about a minute ago. So we're taking from Moscow to here takes about a minute.
Yes.
Okay, everything is okay. Our next film is on the European Commission. We'll be back with more.
Galileo, the state-of-the-art European system of orbiting satellites and ground stations that will provide positioning, navigation and timing anywhere on the globe. It is the joint effort of some 5,000 people in various European organizations.
In the late 90s, visionary European politicians understood the strategic importance for Europe to have its own satellite navigation system.
La décision prise aujourd'hui par le Conseil est une décision clé pour aboutir dans l'un des projets technologiques les plus ambitieux, ou pour ne pas dire le projet technologique le plus ambitieux au niveau européen.
Since then, European Union countries have worked together to design and build the system.
It was the European Parliament and the Council that asked the European Commission to manage Galileo's development.
My strategy is also very simple, built on what we have achieved. I will focus work in three areas: deploying the infrastructure, providing services as they come on stream, and establishing Galileo in the market.
Soon, anyone around the globe will be able to use the Galileo signals, free of charge, to find their position with unprecedented accuracy. And thanks to an agreement signed between the European Union and the United States of America, Galileo will work seamlessly with GPS.
When lives are at risk, Galileo will also aid search and rescue operations by accurately locating emergency distress beacons. Galileo will also provide secure navigation tools for European Union governments. This public regulated service can be used, for example, by the Coast Guard or the police.
In building Galileo, European industries have demonstrated their know-how and excellence in satellite navigation technologies. Over the next few years, as Galileo's capabilities grow, that excellence will be there for all to use, and by 2020, Galileo will be fully operational and provide continuous navigation services worldwide.
And to keep Europe ready for the future, work has already started on the next generation Galileo system, which will provide more features and even better accuracy.
Work has already started on the second generation, is how the film ends. So tell us about the second generation. Where are we going? What can we expect to see?
Yes, at ESA we have been carrying out a lot of studies since several years now to address key topics for these evolutions. For instance, we could talk about increasing the power which is available on board, which is always a limiting factor. So it's something that we are looking at for sure.
How much more power do you need?
Well, it's, the more power you have, the more flexible you can be for maybe also applications which are not identified completely today. So the power is effectively an important driver. But we could have other aspects like what we call electric propulsion, which would be other ways to get to our orbit, or inter-satellite links, for instance, to have another architecture for our overall system.
Okay, we're looking at the gentleman from OHB. OHB are the prime contractors for the satellites, and our next film will tell you all about OHB.
Galileo FOC Satellites by OHB. OHB headquarters Bremen, inside the Galileo clean room on Island 1, where the mechanical integration of the Galileo FOC satellite starts. The last satellite, Flight Model 22, has finished the first part of the mechanical integration and is now ready for the transfer to Island 2 for the first electrical tests. OHB colleagues in AIT are preparing the so-called marriage of Flight Model 18, which means payload meets platform. The modular and flexible design by OHB allows great flexibility in AIT, as well as at the same time it complies with ESA's high-quality standards. OHB's head of mechanical AIT for Galileo, Matthias Tausche, is responsible for all 22 satellites.
We have here in Bremen 7 islands. We have a mixture of mechanical and test islands. So we start with mechanical islands, go over to test islands until we reach our configuration here, what we want to reach in Bremen. And every 6 weeks we finalize one satellite.
Inside OHB's other clean room, the Galileo satellites are tested on system level before their shipment to ESTEC in Nordwijk, where they undergo the environmental tests. By now, all FOC satellites which have already been launched show an excellent in-orbit performance. Parallel to the successful delivery of our FOC fleet, OHB is already actively working on the development of the next generation navigation satellites. Find out more about OHB as a leading space systems company in Europe on ohb.de. Galileo FOC, satellites by OHB.
He mentioned twice in that film FOC. What is that? It's fully something.
It's full operational capability.
Full operational capability. Okay, now that's not new.
No, but this is what we want to achieve by 2020. So this is a very important goal for the program.
Okay, now the program is under civil control, but the signal can be used by others, right? Fire brigades and police?
Yeah, we're having the open service to be used by, anybody for mass market applications. For instance, you have a commercial service for providing additional added value in some application, for instance, increased accuracy. And we have what is called a public regulated service. And this is with a controlled access for the governments.
For governments. Okay, I think we're going to go to one last replay. Here's your last replay before we temporarily leave you, because as we mentioned, this ballistics phase is going to last about 3¼ hours. We won't keep you. We'll take a break and be back with you later. You can stay connected.
Yes, I think via the internet for sure.
Yeah.
And we will be back with the end of the mission at 12:25 local.
Right, 12:25 local Kourou time, or 3 hours 35 minutes into the mission. Here in Kourou, meanwhile, the VIPs are going to be visiting the different launch sites, I think, and I think you're going with them, aren't you?
Yeah, we will show them the Galileo station we are having in Kourou.
Yeah. All right, so everybody will be back here for the second part of the broadcast, which will last about an hour. You'll see separation of the two passengers. So we'll be back at 12:25 local. Enjoy the break, and we'll see you then. Back, everybody, to the second part of our broadcast, our launch of Soyuz, Galileo 11 and 12. Joshua Jampel here, along with Sylvain Lodo of ESA. Welcome back to you.
Welcome.
Sylvain, Ground Segment Manager for Galileo. Hello to everybody listening on the internet at ESA, our industrial partners around the world, and to OHB headquarters in Bremen. We hope you're enjoying the broadcast, all of you. And we hope you enjoyed the break. During the interlude, our invited guests here in Jupiter got to visit the space station. You went with them. What did you see, Sylvain?
Yes, we showed to them the Galileo station here, which is quite nice because it is you have a sample here of all the remote stations that we are having on the system.
Yeah. And what did they think?
I think it's quite impressive.
They were impressed.
Yeah.
For sure.
And we were lucky also in a way because we saw some passes with the antennas.
All right, we're going to go to a review of the mission for those of you who have just joined us. Well, we not going to review the mission. We're looking at the launch replay there. We want to, it's funny, you hear the sound on the tape, and the sound arrives here in Jupiter where we were, what, 20 kilometers, 18 kilometers from the pad, something like that. The sound takes nearly 2 minutes. The sound that you're hearing right now of those engines takes about 2 minutes to get to us, about 18 kilometers away. It's always a very interesting, here's the replay in images. That's the boosters, and then we had the fairing separation, all that normal, up until separation of the second stage, separation, extinction, and then there's the skirt of the third stage, and third stage ignition, and ignition of the frigate. There's a third stage falling away, and you'll see the frigate ignition, frigate, I should say, ignition, first one, there you are. And that burn was for, what was it, 13
minutes, the first one, yes.
And if you take a look on the lower left, our altitude, 23,000 kilometers.
Les phases préparatoires à l'activation du système de contrôle d'altitude sont en cours.
DDO saying everything is okay. When we left you, our altitude was what? Something like
5,000 kilometers, yes, more or less, yes.
Yeah.
So we are much higher now.
So you see, that's the purpose of this barbecue phase, as they call it.
This ballistic phase, yes, you're right. Now we are at the altitude where we need to circularize the orbit. So this is what the second burn will do in some minutes.
And the second burn due to come up at plus in about a minute, actually, you're right. You want to look back at actually the last time we worked together, which was Galileo 5 and 6?
Yes, true.
Yeah.
It was, and we had effectively a problem with this launch.
Slight problem, yeah. Nothing that couldn't be overcome, but the recovery was the thing to talk about.
Yes, of course. First of all, to identify and correct the problem that was faced with frigate. This was done quite rapidly.
Right.
Before the next launch with Soyuz. And then for us to recover the satellites, to keep them in a safe condition, although they were not injected in the right orbit.
Right.
And then in another phase later, when we took a bit more time to prepare for that, we raised what we call the perigee, which is the lowest altitude in such an orbit versus the Earth, to make it in better conditions for this type of application we want to implement. And now we are working to try to use those satellites for navigation purposes.
So this was a slight malfunction on the frigate that...
Now there was effectively a problem, but this was investigated very rapidly. And
confirmation de l'activation du système de contrôle d'altitude.
Okay, now we'll see the results of that coming up because with the post-separation events, we'll have more of that with you. Now, there you see on the screen the ignition of the second frigate burn, the scheduled ignition of the second frigate burn. Coming up right on time, the DDO will confirm that momentarily. This year, we mentioned at the top of the broadcast a record. It's a record year for Arianespace with the 12 launches for the Arianespace family. But it has seen Arianespace deliver for many European institutions launches for the European Commission. And there the DDO is confirming the frigate second burn. Launches for the European Commission we had in June with a Vega launch and the 3 Galileo launches. 4 launches, 7 satellites for the European Commission this year, which became Arianespace's #1 customer.
Yeah, you're right.
And a lot of launches for you, for ESA, Sylvain. IXV, which began the year in February. That's your re-entry vehicle. Lisa Pathfinder, just the first of the month, second of the month. That one, by the way, the 50th launch for ESA by Arianespace. Did you know that? Did we launch 50 times for you already?
Yeah, it's
a well-known figure.
Quite proud. I've got quite proud about it for sure. Yes.
And EUMETSAT Europe's weather organization, had a launch in July. The SICRAL-2 military telecom satellite launched in April. In all, 8 missions, 11 payloads for Europe using the family of launchers. So a big year, rounding out the year in style. Now, all during this long ballistics phase, before the second burn, we call it a barbecue phase, and there's a reason for that, because it's...
Yes, it was because, yes, there are the two phases of the spacecraft. You are having very high difference of temperature between 100 degrees to minus 100 degrees, and this phase is to balance thermally the spacecraft.
So it turns just like a...
Yes.
Like what? Like a chicken on a...
If you want.
Yeah. Okay, now the second burn of the frigate is going along as scheduled. Another 2 minutes in the second frigate burn. Now, what is ahead? Tell us, what can we look...
So then we will go... Still okay, it seems. So we will go now very rapidly then, after this phase, to the separation of the satellites.
Separation of the satellites due at 3 hours, you can see on the upper right of your screen, plus 3 hours, 48 minutes. So we have 7 minutes to go. Frigate flying. Did we talk about the FOC satellites? Did you mention that? I think it was after the Bremen film, the OHB film.
What we could say is that those satellites are developed by OHB in Bremen, and with SSTL in charge of the payload. And this satellite is a new platform compared to the one which was flown with the IOV satellites. And for the payload, there is, on the contrary, a lot of heritage from the previous satellites. In terms of some critical equipment are very, very, very similar for the antenna, for the...
Everything
still okay for the clocks, this kind of equipment.
The clocks, yeah. Can we get back to the clocks? Because we mentioned earlier in the interview with Didier Fevre, he talked a little bit about them. We are orbiting the world's most precise clocks, and there's one each in each Galileo, is that right?
Yeah, in fact, we have, two types of clocks. We have passive hydrogen maser clocks, which are the ones which are very stable. So typically something like 1 second to every 3 million years, to give an idea.
For every 3 million years?
Yeah, if this gives an idea, because it's difficult to imagine what it is.
Yeah, now hang on a second. Do we need that sort of accuracy? 1
yes,
second
this
to
is
3
key.
million years?
This is key for navigation system. Timing is a key parameter.
Yeah.
This is directly translatable to accuracy, so it's very important for the performance. And now we have a second type of clocks also, which are rubidium clocks, which are a bit less accurate or stable, something like 10 times a bit less stable to compare with the.
Let me just stop you. You can see on the screen, this is the scheduled end of the second frigate burn, and we'll be hearing the DDO call out that confirmation in just a minute. Sorry, go ahead. The rubidium you mentioned.
Yeah. So it was. So we have two types of clocks, and this means that we are quite robust to securing that the timing performance of our system are really resilient.
All right. With the second extinction, we are at 25,000 kilometers. Roughly, we should be. I think we're a little slow on the figures there, but when the confirmation comes in, there will be a third ignition actually of the frigate.
Extinction nominale de l'étage frégate à l'instant attendu.
There you have the confirmation.
Début des manœuvres d'orientation.
There'll be third
séparation des charges utiles.
Ignition to pacify or to empty the upper stage of its fuel before it goes into what you call it?
It's a graveyard orbit or cemetery orbit.
Yeah, right, okay. This will come after the broadcast is over and we won't see it, but it's important to remember that the frigate vehicle can reignite up to 20 times.
Yes.
Which makes it quite useful for all kinds of missions, like a mission tonight where we have to go into different orbits.
Mm.
Now, you want to talk about interoperability with GPS, right? Now, what does that mean? The GPS and the Galileo system, that means you're sharing frequencies?
Yes, as seen from the user. In fact, the user would pick up GPS signals or Galileo signals without any
so with
difference.
my little handset or whatever
you could pick up those signals, and this is good for a user because then you maximize the performance and the availability of the service.
So when I buy my handset there, I'm automatically able to pick up Galileo.
Yes, the manufacturers will will include the processing of Galileo signals together with GPS signals because they are of the same type.
Good. The satellites will be put into orbits, I understand, higher than their final operating orbits because they're supposed to go to 23,500 kilometers.
Yes.
Is that right, or 25,500?
Yeah, nominally it's 23,522 kilometers, so which is exactly 300 kilometers above.
Okay, so why is that? We separate the satellites at 23,500 kilometers, but their final orbital slot is at 23,200 kilometers. Why is that? Why do we have to go up and then down?
It's because, in fact, we go straight into what we call the graveyard orbit for our satellites, and in case anything goes wrong, it would be not so good to pollute our operational orbit. So we do it in the graveyard orbit, and then in case something happens, and then when we are having the satellite put at the right position, we also correct slightly the altitude.
Now, how does the satellite go from 23,005 to 23,002?
We use
on its power?
Yes, we use the propulsion system of the spacecraft. So we have a number of thrusters that we use to effectively do this kind of navigation, if you want, from the current situation to the final slot.
Okay, so the satellite uses some of its own power to get to its final slot.
Yes, correct.
Very good. A minute to go until confirmation of separation of our two passengers. Remember, they will be separated together. One off to one side and one off to the other side. I suppose that's to eliminate any chance of collision.
Yeah, of course, at this stage, we try to be safe for this kind of event. Yeah.
Okay, a minute to go. Always a moment of concentration in the final seconds before satellite separation. Remember, these satellites representing years of work. Is that fair to say? Years of work?
This is correct. In this case, yes. Many years of work, yes.
Yeah, many years of work for most of the people involved here, I would say. So everyone in the hall very focused. What's going through your mind now as your satellites are moments away from separation?
So now we expect effectively that separation happens because after that moment, a number of critical actions will take place and our satellites will wake up. And then they will go into an automatic sequence, and then we will see, hopefully, very rapidly that they are doing the job as we expect.
That we will get to with, because we have a series of, what do you call them, post-separation events that will be called out by the DDO, I suppose?
Yes, there will be a number of announcements after the spacecraft are separated.
We've reached the schedule point of separation. You can see on the screen that Galileo 11 and 12. Which one's 11, which one's 12? Doesn't really matter, does it?
No, clear. I cannot tell you. Anyway, these are synthetic images, yes.
All right, so if we trust the images, we have the good news. But as you notice, nobody in the hall here is applauding because we're waiting for the first confirmation from the DDO. And then we have a long list of signals, acquisition of the signal. There we go. Separation confirmed by the DDO, but still we're waiting for other confirmations from the separation confirmation we just had was from the launcher. Is that right?
Yes, now this is coming from the launcher correctly, yes.
Okay, so now we're waiting for the signals.
Yeah, now what will happen now, the satellites will wake up and they will start transmitting. And this signal we are expected to acquire from our now stations, which are to be used by the LEOP Operational Control Center in Toulouse.
Okay, so we had telemetry. Okay. We had telemetry sent by the launcher saying I've separated the two satellites. And now we're waiting for the signal from the satellites. Once they wake up, as you say, they will send some telemetry down to the stations, and then that will come into here.
Now they will provide the feedback that those signals have been acquired. I think now we know that the satellites are properly separated. and we wait now for the confirmation that effectively
they're transmitting telemetry and that they're in the right position, or does that come later?
This we will check a bit later now. First of all, that they are starting the automatic sequence, and then in 20 minutes, more or less, we will be able
20 minutes,
to confirm if they are exactly on the position we were.
That they're where they should be.
Exactly.
Okay, so we have a little bit of a wait. Did you finish talking about the GMS, the very complex system? Because in your two control centers, I don't think we mentioned that. In Fucino?
Yeah, in fact, well, the main control center for the GMS is in Fucino. Now we are also having a backup in Oberpfaffenhofen in Germany.
In Germany. Okay. And 5 stations sending messages to the satellites, which we'll talk about. But first, we'll go to a replay. This looks like one from right on the site there, near Sinnemarie. If you've been out here, Sinnemarie is about, as I said, 20 kilometers
from here, yes.
From the Jupiter Control Center. That's where the Soyuz pad was built. Nice shots. They were talking about the weather, and look, the weather out at the base is blue skies. Very nice.
Mm.
Soyuz on RC. All these cameras, we have about a dozen cameras, I think, along the base, not counting those that are here in Jupiter.
Mm-hmm. Giving different views of the same.
Yeah, and the VIPs that you accompanied during the break, they get to watch the launch from one of these 6 or 7 observation sites that we have here along the base.
Clear. So we have now confirmation that we have received the signal from the 2 satellites from our LEOP control center. So this is very good news.
So good. So that's the first. That's the first confirmation that we needed.
Yeah. Now it seems that the satellites have started to do what they expected to do, which is now they will in particular.
We're going to hear from Stefan Israel.
To go, so the preliminary statement is good. What we are now doing, we are waiting for some more information from the customer, from the satellite. We should have this information within 30 minutes, so we will be back in 30 minutes to give final confirmation that things have been as scheduled. So just wait a little bit, 30 minutes, but preliminary information are going in the right direction.
Pour
Let's wait 30
information,
minutes.
acquisition de la télémesure des satellites Galileo par les stations Sol.
Has Stefan Israel just Stefan Israel just setting the scene for us. We have had initial confirmation of acquisition of the signal from the satellite. You heard the DDO say that, and what we're doing now is we're waiting for additional confirmations, which all should come one after the other in about the next 20 or 30 minutes.
Yes, that's correct. So now our stations, in particular, we have one in Hartebishoek in South Africa, and another one in Kerguelen, which are now tracking those satellites. So it has been confirmed that they are receiving the telemetry. So this is
that's good.
Very good. This is what we expected, and in a few minutes we will now integrate this information, and we will be able to derive if the satellite is also in the right position.
Where it should be. Okay. Now, how come we're not able to determine if the satellite is in the right position earlier? Why does it take the 20 minutes?
No, it takes some minutes just to compute that, because the satellite at this moment is in fact doing a number of things, and for instance, at this altitude, we could also think about having a receiver just to give the position to transmit it, for instance. But we don't do these kind of things. No, we use our means on the ground to determine the range with the signal, and then determine accurately the position with
Les paramètres à bord de l'étage frégate sont normaux. Les manœuvres d'orientation au profit de la passivation ont démarré.
All right, everything as it should be?
It should be, yes, for Frégate now, for the final stage of its mission.
So you were saying that we can't compute more rapidly to find out
no, this is normal practice. Anyway, now we are, the satellites are hopefully, if everything has gone nominally, they are in very good conditions. They don't,
which is probably
we don't, risk anything.
Yeah,
sure. Now it's good that the satellite is doing the other things we are expecting it does, in particular deploying the solar panels, and then making a number of checks and to put itself in a safe condition, which this will happen when finally the spacecraft will face to the sun, to be able then to recharge the batteries and then to be safe.
And then it's autonomous.
Yeah,
more or less. Yeah. Good. So we're waiting for the next one. We're waiting for initial status of the satellite. Is that what I can call it?
Yeah, and we'll get now two things in the next minutes. We will get the confirmation that the satellites are hopefully in the right orbit.
And will we get confirmation that the solar array deployment has begun?
We will start to have just at the same moment, more or less, the confirmation of where the satellite is in its sequence to do a number of automated activities, so including the deployment of solar arrays. Yes.
And then it gives a power status or a status of systems.
Well, yes, it shows. Yeah, it indicates if what was planned to be done has effectively been done as it was expected, and then at that moment, I think this is what was said before by Arianespace, that they will indicate a first status of where we are.
Status. Okay.
About 4 hours after Soyuz liftoff and falling separation from the Frégate upper stage, the satellites will go through an automatic initialization sequence, controlled by their onboard computers. Firstly, to ensure the good stabilization of the satellite attitude, then to deploy the solar arrays, point the satellite toward the sun, and recharging the onboard batteries after the launch phase. The sequence will be closely followed up by the Galileo Loop Control Center at CNES in Toulouse through dedicated Galileo ground stations. After reaching these stable conditions, the two satellites will start a sequence of planned testing to confirm the good status of all the satellite platform equipment. This initial operation phase will be completed in the next 6 days. After that, the two satellites will be repositioned in their final operating position, and this will take approximately 3 to 4 weeks. Afterward, the payloads will be activated and an in-orbit testing phase will start and will last for several weeks, aiming at characterizing the Galileo navigation payload signal performance and the Galileo search and rescue payload performance. At the beginning of spring 2016, the two satellites will be included into the Galileo constellation nominal operations. I would like to take this occasion to thank OHB, SSTL, Arianespace, CNES, and the ESA teams for the excellent work performed, which led to another key milestone for the Galileo program. Thank you.
There's the Galileo team, part of the Galileo team, awaiting, as we all are, the various confirmations. The Galileo program was born in 1999 when Europe decided to build its own satellite-based navigation system, and since it has really become the reference launcher for constellations, hasn't it? Because there's Globalstar, Galileo, there's OneWeb, O3b.
No, that's correct. Yeah, all these are good references. Yes.
Arianespace signed. We mentioned the record year in 2015. It's also a very good year for contracts, I might add. In 1915, signed 14 satellites to go to GTO with Ariane, one O3b, and 21 OneWeb launches signed for Soyuz. That's why I say it's becoming the launcher reference for the constellation system. So in this year, signed for 21 launches for Vega. That's something. For Soyuz, 3 launches for Vega, total of 2.2 million euros. So we're ending the year I think we couldn't be better.
No, that's right.
We are waiting for confirmation of the initial status, power status, solar array deployment, all these things. We're 4 hours into the mission. We're going to go to a film in about 2 minutes that's going to give you, tell you everything you've ever wanted to know about all the applications, from EGNOS to search and rescue,
yes.
even farming, precision
yes,
farming.
Precision
now,
farming, yes.
Now, there's something you wouldn't think that...
yeah, this is quite a useful application of accurate satellite navigation.
Yeah, no, how does it help farmers?
It helps them a lot, for instance, optimizing the use of fertilizers, just to use what you need, where you need. This is very important, and you increase with that really the efficiency. Yeah.
Okay, so it's also an environmental
yes, very much, yes.
approach, I would say. So all that is coming up in the next film. Farmers, search and rescue, you mentioned something about the...
yeah, there is a specific contribution from Galileo to search and rescue, not only with payloads, which are on board all the FOC satellites, but also on the ground. We have developed a ground segment, which is participating to the overall SARSAT-COSPAS activities in there. So saving, it will be used to save lives, thousands of lives every year.
So it's not only, I'm glad that you're mentioning all this, because it's not only just like in your car, how do I get from point A to point B, but there's all kinds of other uses and applications for it, even sports, in-depth analysis for sports, I'm reading here. How
yeah, when you can use, the positioning information, if you combine it with any other type of information, you can develop very important, diverse applications.
All right, we're going to have this film for you now on EGNOS and Galileo and all the applications, more than you could ever dream of. Back with more later.
What do a farmer driving his tractor, the captain of a large cargo ship manoeuvring in port, an environmental expert surveying forests, a truck driver transporting hazardous goods, and a banker trading commodities have in common? They all rely on satellite navigation. Satellite navigation goes far beyond guiding us to our destination in our cars. It allows farmers to use less fertilizer, ships to navigate safely, operators to run road networks, local authorities to manage infrastructure, power grids to access the extremely precise timing needed to manage lines, bankers to timestamp operations, and it even enables efficient wildlife protection. Europe contributes to making positioning more accurate, reliable, and available through its 2 state-of-the-art satellite navigation programs. EGNOS, the European Geostationary Navigation Overlay Service, is Europe's first concrete venture into satellite navigation. Its geostationary satellites and network of ground stations increases the accuracy of existing satellite positioning signals, like GPS, while providing a crucial integrity message, informing users in the event of signal problems. Galileo is Europe's independent global satellite navigation system. It will provide highly accurate, reliable global positioning under civilian control. The fully deployed system will consist of 30 satellites and associated ground infrastructure and will be interoperable with GPS. EGNOS today and Galileo in the future can save lives, on land, at sea, and in the air. Landing procedures using EGNOS enable search and rescue helicopters to land safely on helipads, like those next to hospitals, even in bad weather. And civil protection services rely on accurate mapping and positioning when responding to floods, forest fires, or earthquakes. Satellite positioning will also save lives on our roads. eCall is a pan-European system that enables vehicles involved in a crash to call the nearest emergency centre automatically and send the exact position of the accident, allowing emergency services to get there faster. Galileo will offer a global search and rescue service. It will complement existing systems and ensure better coverage so the distress signal can be picked up without delay. It will also increase positioning accuracy of distress beacons, in some cases from several kilometers to a few meters. While EGNOS and Galileo will be vital in case of an emergency, they can also play an important role in prevention and safety. Aircraft use EGNOS to make safe, precision approaches to smaller airports and helipads, even with bad visibility. And trucks transporting hazardous goods can be permanently tracked, so we always know where they are. Advanced driver assistance systems will combine sensor and satellite information, including Galileo data, to help drivers avoid accidents or warn of obstacles ahead. The maritime sector was one of the early adopters of satellite systems, and EGNOS and Galileo make navigation more precise and safer. Millions of farmers already rely on satellite navigation to reduce the spraying of fertilizers or pesticides and to lower fuel consumption. In the air, precise positioning enables more flexible approaches for aircraft, including curved segments that are substantially more fuel efficient and will reduce noise pollution. EGNOS and Galileo will help authorities track down marine polluters and protect environmentally sensitive areas, as well as protecting fish stocks from overfishing or marine poaching. Accurate mapping helps conservation authorities manage natural parks and forests, whilst guiding people enjoying nature. Knowing exactly where you are at any given time can improve quality of life. Accurate and reliable satellite positioning can help the visually impaired navigate more safely and warn them of potential hazards. And smartphones will use Galileo to power a range of applications. EGNOS and Galileo will enable improved air traffic management and access to airports, which means less delays, diversions or cancellations. While road and rail management systems relying on satellite positioning will help manage traffic to get you to where you are going faster. If satellite navigation is crucial today, EGNOS and especially Galileo will form the foundation for a range of new innovative applications in the future. Fairer insurance for cars, in-depth analysis for sports teams, warning systems for earthquakes, weather forecasting, mobile phone apps to streamline traffic, environmental monitoring, and even beacons to manage livestock will be able to access reliable and accurate positioning. Companies across Europe, large or small, use satellite positioning to streamline operations, saving time and money. It also powers lesser-known applications like providing power and telecom operators with extremely accurate time stamping. This will generate substantial socio-economic benefits to Europe's economy and its citizens. Jobs and business are being created for companies of all sizes, while spin-offs coming out of the technology being developed are used by entrepreneurs and researchers outside the space industry. Farmers, bankers, surveyors, captains, conductors, pilots, firefighters, and European citizens from many walks of life will rely on EGNOS and Galileo to power services that enhance efficiency, safety, protection, and economic growth.
EGNOS was developed for aircraft, right? But it does more than that. It was developed to help guide aircraft, but there's a lot more to it.
Yes, you have also a kind of open service on EGNOS, and it can be used for other applications requiring, let's say, accurate positioning. So we talked about precision farming before. There are applications on precision farming using EGNOS.
Right, and for precision landing of aircraft, I guess.
Yes, of course. This is the main mission of EGNOS.
Okay, very good. Now, there's going to be an updated version of EGNOS for
yes,
for Galileo?
soon. Yes, by the end of the decade, more or less, there will be another version of EGNOS which will be able to serve also Galileo satellites.
Now, the services that we're talking about, initial services begin next year, right?
Yes, this is what the Commission will declare next year, and this is important for the adoption of Galileo in many applications.
Okay, so next year sees the real unveiling of the Galileo services because you'll have your how many satellites will you have deployed?
We will have 12 satellites, which will be deployed, and a subset of them will be available constantly. And this is what will support the use of Galileo satellites under this basis.
Okay, so we need at least 12 to start initial services.
It's a good basis, but we will. In fact, it is an intermediate step towards getting the 30 satellites deployed by the end of the decade.
Okay. We're waiting, I think, for another launch replay coming up for you. And then we'll be back with, there it is. I think that's even closer than the last one.
Yes, another angle. So it seems the satellite seems to be doing what we expect from them. So we will have confirmation soon, but the intermediate steps seem to be indicating that we are having a good mission up to now.
So where are we now with what you're receiving from the satellite? The solar panels have begun to be deployed?
Yeah, this is one of
the
first. Yes, we are now in the process of having the solar panels being deployed. And I think we are probably progressing on the computation of the orbits of the satellites.
And all these computations are done at the ground stations, or is this done at Toulouse?
It's done in Toulouse currently, yes, in
VS13. Because the Toulouse is the control center.
Yeah, for this stage of the mission, yes. Now they are taking care of the satellites, checking what is happening.
So in Toulouse takes care of the early orbit phase, is that right? Or
yes.
do they control everything afterward as well?
Well, they will take control of the satellites for the first week now. And then it will be handed over to the control center in Oberpfaffenhofen.
Ah, right. Okay. Very good. Well, you know, it's curious because you're talking about satellite navigation. You could say, well, you're looking into the sky for guidance, right? Without being religious about it.
This is a principle, yes. Yeah.
Yeah, okay. You're looking into the sky, which is exactly what people have always done.
Correct.
Right? Because you had the ancients looked to navigate from the stars.
Yes.
Right? And I recall, for instance, the Polynesians used the stars in their outriggers to make it up to Hawaii, where there's a link between those two civilizations.
Yes, of course. Yeah.
And then and then I remember just recently, Hawaiians retracing the route from Hawaii back to, I think it was Tahiti, navigating only by the stars to prove that it could be done. So I'm not saying there's nothing new, but the system seems to be
same
similar.
Principle, exactly.
Right? And then navigation by the stars. So, and then eventually, I guess we moved away from the sky. Is that possible to say? Because we had what? We had the compass.
Yeah, correct. Also, yes, sextant. Then, yeah.
And then the sextant, right? The sextant came, and then and how did that work? Second, you use the angle of the stars, triangulation, right?
Yes, exactly. Same principle again. Now it's much more comfortable with a system like Galileo, for sure.
So sailors who use now triangulation, I mean, it's the same thing.
Same principle, exactly, yes.
Basically, okay. And then, so we moved away from there, we moved to clocks, mechanical clocks, and then to quartz clocks, and now today...
to atomic clocks.
Atomic clocks aboard Galileo. So I think it's interesting that it is the same philosophy, if I can say. All right, where are we? We have had acquisition of the two signals from the two satellites.
Yes, this was confirmed effectively 20 minutes ago, yes.
By the launcher.
Yeah.
And then, so the computation on the ground is starting to tell us that...
In principle, it seems we are getting, having the satellites which are on the orbit which is expected.
Okay, so we're where we should be.
Mm-hmm. And now we wait for the status of the satellites, 11 and 12, to check that they have hopefully done what we were expecting, in particular to deploy the solar panels, and that the other parameters are also okay. So we will see. It should come now rapidly, I think.
The smiles on the faces of the CNES people, the CSG people, and the Galileo people would seem to confirm what you're saying.
Yeah, yeah. It seems to be a good sign, but we should be a bit cautious and wait a bit, some minutes.
Sure.
But it should be effectively.
Sure.
In this direction.
And I think we should have confirmation in about a minute, right?
Yes, it's about to come. Yeah, we're just waiting for that.
Okay. In the meantime, just a couple of figures for you. Soyuz, tonight's was the, do you know what number launch this was?
I think it's 1,852nd.
52, exactly right. Yeah. Congratulations. This was the 1,852nd launch of a Soyuz since it began. And just as recent as Tuesday was the 1,851st Soyuz, which took off from Baikonur. You can see it's a vehicle that's used. And the 1,850th went up on December 5th. So there have been 16 Soyuz launches worldwide this year. So when we say workhorse, reliable workhorse, and all these, of course, different payloads and different orbits and things, and tonight.
Clear.
So we're still waiting for confirmation. Yeah,
of course, we are actively checking the information which was sent by the satellites to understand exactly where we are.
I mean, you think Soyuz was originally a missile. You remember that? It was the
correct.
R-7 was the first intercontinental ballistic missile developed in 1953 by not Werner von Braun, but the other one.
Sergei Korolev.
Right,
yes.
The Russian scientist. Very good. R-7 successfully tested in 1957. That's 60 years ago almost.
Yeah, quite.
Yeah, and that was in August, the first test, and in October that same year, it put Sputnik in.
Yeah, just after. You're right.
Yeah. The Soyuz pad here, it's another interesting note, which we just learned. The Soyuz pad here is the 7th in the world, and it's the most recent one, but not for long, because there are 2 at Baikonur, 2 pads for Soyuz, 4 at Plesetsk, mostly used for military launches, I think, but
probably,
I'm not sure. Yeah. But the gantry, this is the interesting bit, the gantry is only used here, but that's going to change. Why? Because a new pad is being built in Russia at Vostochny, in the eastern part of the country.
Close to Vostok, yes.
Close to Vostok, yes. And they're building a gantry there for the dedicated Soyuz pad. There will also be facilities for other launch vehicles, but the Soyuz pad should be ready to go next year.
Yeah. So yeah, this approach of the gantry is quite impressive, and it's very efficient for the operations, the final operations on the launcher.
That's what they thought. That's what they decided before building it here, because exactly as you said, it's more efficient. Lets people get into into all the stages.
Yeah.
And the gantry, as we mentioned, pulled back about an hour before
the launch
liftoff. So we are still waiting for our confirmation of the confirmation that all is well. The satellites have been separated, right? That's for sure.
This is for sure.
Right. The satellites have been awakened, so they're performing, they're doing things.
Correct. This is also achieved.
Okay. And they're where they should be.
It seems they are effectively on the right orbit, and now it seems they are also in good health. Yeah.
Confirmation de l'injection sur une bonne orbite des satellites Galileo.
Well, you don't need us to comment.
Et maintenant, de la part de TIOV, quelques images sympathiques pour le succès de ce lancement.
Well, you see that our Christmas launch is not over. That's the music from...
It's Christmas.
Christmas music. It's not
Yeah.
Star Wars.
No.
Okay. Well, you don't need us to tell you that, obviously, we have had a successful confirmation of... in the hall here, you can see the images on the screen projected in above the heads of the operational people in the fishbowl. And it looks like, what is it, Star Wars or 21st century Santa Claus. Yeah, so that's nice. With a nice happy Christmas, Merry Christmas, and a Happy New Year message. So we know that Soyuz has accomplished her mission.
Yeah, so it's, and now anyway, for our satellites, of course, it's going on. And we will have a number of checks in the next minutes. Hopefully, it will confirm that the satellite is continuing to implement all the activities which are necessary for them to become fully safe.
Mm-hmm. So, as you can see, the confirmation of acquisition of the signal from GAT 11 and 12.
Okay. Mesdames et messieurs, ladies and gentlemen, distinguished guests, dear Commissioner Bienkowska, Arianespace is delighted to confirm that the FOC 11 and 12 have been safely separated on their targeted medium Earth orbits. The satellites have successfully performed the initial steps of their launch and early orbit phase operations. For the third time in 2015, Galileo has been a perfect success. Indeed, Galileo is accelerating along the path towards building Europe's independence in the field of global positioning, navigation, and timing. Next year, Ariane 5 will enable us to reach another important milestone with the deployment of 4 more Galileo spacecraft on a single launch. In 2017 and 2018, 1 more Soyuz and 2 more Ariane 5 ES will continue the job, leading to 26 Galileo satellites and full operations. Arianespace is very proud to be a partner in Europe's flagship space program. Let me express my sincere gratitude to the European Commission, DG GROW, and Commissioner Bienkowska for their continued trust in Arianespace launch services. I want to highlight 2 things. The first point is that Commissioner Bienkowska, upon recommendation from ESA and Arianespace, has been the one who finally has decided to go for 3 launches this year and 1 Ariane next year. It was your decision. You have announced this decision during the space conference in Brussels. It was in January. This decision was not easy to make, and you made it. I want to say a second thing. To attend the launch for everybody is always a risk, and you are here with us tonight. So I really want to thank you for your presence and for this decision, because it is really important for us. So I want also to thank all the Galileo team, all the DG GROW team, for sure Mr. Delso, Matthias Petschke, because we have worked a lot together to achieve this success. Tomorrow, we hope that European space ambitions will broaden and will envisage, in addition to Galileo and Copernicus, new chapters for global connectivity, secure defense communication, and COP21's environmental monitoring. In so doing, we see the European Commission as a key anchor customer for future Ariane 6 and Vega C launch services. For sure, I want now to extend my gratitude to the European Space Agency, Galileo Design and Procurement Agent for the European Commission, and as such, Arianespace direct customer for this launch. I want for sure to thank Jan Werner. Jan is attending our launch at ESA headquarters because he shares today an important ESA council. So Jan, thank you very much for your trust. And I want to have a special word for Didier Fèvre, Didier, ESA NAV Director, with whom we have closely cooperated for the success of the Galileo program. Really, merci beaucoup Didier pour tout ce que tu as construit avec nous. VS13 was also the 50th mission conducted by Arianespace for ESA. Today, our relationship took another historic step forward when we signed the contract with ESA for the launch of NASA's James Webb Space Telescope. It will be in October 2018. This is the second very good news and very important news for Arianespace of the day. Last but not least, I want to congratulate OHB for the on-time delivery of the 2 satellites. OHB is the key player of the satellite on the satellite side, and for sure also a very important shareholder of Arianespace. We are very happy to partner inside Arianespace and for the success of Galileo. Before giving the floor to our dear partners and customers, I want to say a few words on what has been 2015. Thanks to the flawless operation of our launch vehicle family, 6 Ariane 5, 3 Soyuz and 3 Vega orbiting 21 satellites, equally shared between institutional and commercial customers, we have recorded 12 successful launches in a single year from the Guiana Space Center. Among our 12 2015 launches, 3 Soyuz, 3 Vega and the equivalent of 1 Ariane have been dedicated to European institutions and governments. We have illustrated better than ever our mission to guarantee autonomous European access to space. In doing so, Arianespace has also paid tribute to sustainable development in the year of COP21 with 5 launches, 3 for Galileo, 1 for Sentinel Copernicus with Sentinel-2A and 1 for EUMETSAT with MSLG-4, which will have a direct and positive impact on our environment. 12 launches in 2015. This was the target. This was our motto during all the year, and now it's done. For that, I want to thank and congratulate all our partners. Our partners are belonging to industry when they are our prime contractor for the launcher. Today with Roscosmos for sure, and I really want to say how confident and deep is our partnership with Roscosmos, with Airbus Safran launcher, obviously, when it comes to Ariane 5, and with Avio ELV for Vega. So I want to thank all of them for the amazing availability and reliability of the rocket. I want to thank ESA, which is for Arianespace more than a partner. It is a tutor, a protector, and all what we have done this year would not have been possible without ESA. I want to thank CNES CSG. We work here hand by hand together all day long. It was our common challenge to be in a position to deliver 12 launches, and we have done it. I want to thank all the employees of the launch basis, the ground industrialists, who made this outstanding achievement with us. For us, I want to express my gratitude to Arianespace team. For Arianespace, this year has absolutely no precedent. It is a record with our family, 12 launches. We made 1 more than last year. It is a record in terms of sales. I can say today that sales are at 2.4 billion euros for Arianespace in 2015, which is absolutely with no precedent. This success is a success of a team operational, commercial. All the team of Arianespace have made a really exceptional job this year, and I want to thank them for that. Thank you very much, and now I leave the floor to our partners and customers, and for sure to Commissioner Bienkowska.
Thank you, but I think that firstly we have to say thank you to all of the Santas behind us, because there are very nice things happening behind your back, Stefan. So, ladies and gentlemen, I'm really honored and happy to be here today with you. We have just witnessed 2 Galileo satellites successfully reaching the orbits. It is a great moment, also for me personally, because for me it is the first time to go through such experience. But it's also a moment of reward to all of you, all of us, if I may call it like this, on the program, all of us working on the program. In January this year, as it was reminded before, I said that the Galileo program must be a success, and for now we see it is a success. And I committed to all of those present there that we do our best to ensure it. And those 9 months, or even the whole this year, we have had 3 launches, all of them successful. It was a challenge, of course. It took time, it took efforts, it's dedication from all of you and many others, especially Santas. I would therefore like to thank again, on my behalf, on behalf of the European Commission, to all of partners of the European Union for their involvement and dedication to Galileo program. So the CNES, European Space Agency, Arianespace, OHB and their respective partners, and the numerous high-tech companies of the European space sector involved in Galileo. I would also like to thank very, very much my own services from the European Commission, from DG GROW. We have now a space industry of 12 satellites and a ground infrastructure supporting them. But of course, there is still a long journey ahead of us. To deliver on Galileo, we'll focus on, just shortly to say that we will focus on following 3 objectives. First, we must continue to build up the infrastructure. The launch schedule is clear. It was also said before. Our challenge for the next year is to use the Ariane 5 launcher to bring 4 Galileo satellites into orbit. Second, I think this is the most important, we need to deliver services to users. Our aim is to provide initial services from the end of next year probably, but during the course of next year. Finally, we need to make sure that we take all of the advantages of this infrastructure, because building infrastructure and the infrastructure is not, of course, the end in itself. Therefore, it will be also important year for European space policy, I mean the next one, because the European Commission will propose a European space strategy to maximize market opportunities for space-based applications and services. I think that now we can honestly say that Galileo is really the success, but also because never before has Europe collectively invested its know-how and resources in a single project. Now we are there and we have to continue. Thank you very much. Thank you to all of you.
Madame la Commissaire, Jean-Yves, Stéphane, chers amis, chers collègues.
Mrs. Commissioner,
je crois que ce soir on
my
vous offre un beau
friends,
cadeau de
I
Noël.
think that tonight we've given you a great Christmas
La joie des
gift.
collègues ici montre
You see the
combien
joy
nous
of
sommes
all my
satisfaits
colleagues
aujourd'hui
here. We're
d'avoir
very
accompli la mission
satisfied indeed
de lancer ces satellites
because
Galileo.
this was a successful mission.
Et
We've launched
c'est un
two
grand moment
Galileo
pour nous. N'oublions
satellites.
pas les collègues
It's a great
également à
moment for us,
Toulouse
and
qui s'occupent aujourd'hui
we
de nos
don't forget
satellites.
our
Quelques
colleagues
mots sur leur
in
état.
Toulouse.
Après une injection
Let me
parfaite,
tell you a few
merci
words
Arianespace et
about
merci
the
à nos
satellites
camarades russes
after a perfect
qui, une nouvelle
launch,
fois,
and
ont
thanks
réussi
again
un lancement
Arianespace.
parfait
Thanks
Soyuz.
to our Russian friends.
La séquence de déploiement du satellite s'est déroulée de façon parfaite.
The sequence of the
Donc
satellites
les collègues de HB, une fois
was
de plus,
perfect.
ont démontré la
So once
qualité de
again,
leurs
we've
produits.
proven the
Les
quality
équipes à
of our
Toulouse et dans toutes les
products.
stations
Our
autour du
Toulouse
monde,
teams, the
Kerguelen,
teams in
Perse,
all the
Angara,
stations around the world, Kerguelen and others, have acquired the satellites on time at the right moment. And right now, the satellite subsystems are exactly as expected. Stéphane wanted me to say something, but I'll tell you that this mission is a success in 12 years. But 20 minutes after the success, I eventually decided to say a few words. Toulouse is in charge of the satellites with the CNES and ESA teams. OHB is making the satellites that we're going to launch next year. Ariane 5 will be ready beginning of next year. It should be launched sometime after next summer. A great Christmas gift once again. What's expecting us now is an Ariane launch in 2016, and we are ready. And a few words as well, because on the 28th of December, 10 years ago, many of us were in Baikonur. And it was at that moment that Europe started this program of space navigation with our products manufactured by the SSTL people. These programs are still working fine, and it's a great success for Europe. Europe dared do it, thanks to EU, thanks to the Commission, Mrs. de Palacio, and all the others, all the team of the Commission, of ESA, Mr. Rodota. They all supported the program. 10 years afterwards, we have 12 satellites in orbit, and we have a program for the future. So thank you, and see you soon. Thank you.
Dear Commissioner, ladies and gentlemen, chers amis, I am of course very glad that our satellites have been properly delivered. Thank you again to Arianespace and to the complete Soyuz team and CSG staff to have made it. I now wish, of course, that our two satellites, Guiana and Line, will deliver the same extraordinary performances as their predecessors. This is the fruit of the excellence of the European space industry, and we should be very proud of it. It is an asset for European competitiveness in the space domain. I am also very proud that at OHB and at SSTL, we achieved the challenge of series production, which is a guarantee of a timely implementation of the Galileo full operational capability in 2020, if our customers, of course, keep their confidence on us for the next batch of satellites. Because we are all aware that the development of the downstream market, the applications, and the services using the Galileo signal are key to the success of the program. Having performing satellites is a condition, necessary condition, but time to market is of utmost importance. Now, I would like to thank all the teams in Bremen, Nordwijk, Guildford, who have worked very hard to make this success possible. Je veux aussi profiter de cette occasion
also like to thank in particular Didier Febvre and his team for his constant support in the challenge that we have faced and for the success.
Für die Familie Fuchs und alle meine Kollegen in Bremen wünsche ich eine gute und frohe Weihnachtsfeier heute Abend. Merci à tous.
Madame la Commissaire, Mesdames et Messieurs,
Mrs. Commissioner, ladies and gentlemen, the new success that we have just witnessed is a new step in the development of a strong European space industry, and it is a good illustration of how pertinent the European policy is as far as space is concerned. Galileo is becoming a reality. The challenge now is to go on launching satellites, of course, but the challenge is also to make sure that Galileo is used by as many European citizens as possible, and this is why we are working so hard at the Commission in Brussels and in Prague, GSA. Then this successful launch from this Guiana Space Center proves that it's very interesting to have a whole range of launch vehicles for different types of payloads. Some are big, some are smaller. You said that it started in Baikonur. This is right. That's where it all started. And we want to have a sustainable capability, and that's why Europe took that historical decision last year in Luxembourg. I'm talking about the Ariane 6 program, of course. This new success illustrates the huge possibilities provided by the Space Center here. We have great teams. We have a commitment that is so admired by everybody. We have been able to prepare 12 launches. We have been able to have ready launch vehicles ready to be launched on time. So I would like to thank and congratulate all those who've made this European success possible. People working at the level of the Commission, ESA, Arianespace, Starsen, in the industrial world, in Europe, in Russia, and in the CNES. And this mission is illustrating the competencies of the CNES here in Guyana. CST, our colleagues, for example, have given us the first information about the health of our satellites. Thanks to your know-how, your expertise, policies, your commitments. You represent Europe at its best. And after the success of COP21, we have now put satellites at the heart of climate issues. With this 12th successful launch in Guyana, 2015 ends in a great way. A few words to my colleague of ESA watching me in Paris. Unfortunately, I was not able to co-chair this meeting of the Council, but I'm sure that Beau replaced me in the best possible way. Anyway, I would like to wish you excellent Christmas, excellent end of year, and we'll meet again next year for another great European space year. We'll start this year with new launches here and elsewhere. We're going to Mars next year. Thank you. So, ladies and gentlemen, I will conclude in French, if you don't mind. Beginning of my holidays, I suppose. I would like to tell you that Arianespace will be back here in the Space Center on the 27th of January for Intelsat. Intelsat will be is our loyal customer. So on the 27th of January, we will put Intelsat 29E into orbit from this Space Center. And as the Commissioner explained, as other speakers said, we are working hard, we are going on working hard to be able to deliver an Ariane 5 ES for Galileo in autumn 2016. So thank you all. Have a great end of year and great holidays. And see you. Thank you.
So as the Christmas hats flicker in the background, we will say goodbye. Any last words, Sylvain?
My last words would be for the persons now working in Toulouse and to try to monitor our new satellites. So this is now they have still a long shift to go through. So I'm thinking about them and also for OHB persons in Bremen in particular, but because for them it's of course also a hectic period now.
All right, as you can see on the screen, we're recapping the year in pictures. And over these pictures, we'll say goodbye. The big news from French Guiana is that Arianespace and Soyuz once again delivering successful launch of Galileo 11 and 12 for the Galileo constellation. A record 12th launch of the year, delivered the 32nd and the 33rd satellites launched by Soyuz since she started at the CSG in 2011. So that's it for this banner year. Next year begins, as you heard from Stefan Israel, with a launch at the end of January on an Ariane 5. We will be here, and we hope you will be too. Until then, Joshua Jampo with my friend Sylvain Laudeau, on behalf of everybody here at the Space Base, saying thank you for being with us. We hope you enjoyed it. We certainly did. Have a safe and a pleasant holiday season and a very happy New Year.
Séparation de Skybuster. Séparation Arsat.
Number 400, look at the celebration.
Séparation Arabsat 6B. Séparation Majestat 15. Séparation de l'ESA Pathfinder confirmée par le projet satellite.
Là, cette fois-ci, on peut applaudir, tout le monde se lève.